This is a previous year NEET 2021 question from electrostatics or the capacitance and potential. So in that chapter, equivalent capacitance of the combination shown in the figure. So we have a circuit given, a capacitance circuit is given. We have to find out the equivalent capacitance between the point A and B. First of all, you have to look carefully at the circuit. See, if you look at this point, see this point and this point, you can see that they are effectively short circuited. That means it's connected through an external cable or conductor. That means there is no potential difference across this capacitor because both are same point. That is a major thing you have to understand. That means we can neglect that capacitance. If you are applying same, there is no voltage potential difference across a capacitor, that is not going to store any charge. That is a basic logic you have to apply here. That means this can be reduced into a two capacitor system just like this. So it is effectively two capacitors connected in parallel combination. So this is a final circuit. Now here we have to find out again, we have to find out the effective capacitance between A and B. I hope all of you understood everything. Now assume that we are connecting a voltage source across this capacitor parallel combination. So something like this. Two capacitors and we are connecting a voltage source like this. Assume the voltage is V, okay? The voltage is V. In any parallel system, you know that same voltage will be available for all the individual components. That means here voltage V will be experienced, V will be again experienced because it's a parallel connection. Now you know that the capacitance is given, everything is same value. So this capacitor as well as this capacitor have same capacitance. Now you already know that when you give a voltage across a capacitor, we can store some charge if it is a direct current. So the charge in a capacitor is proportional to voltage, or we know the expression Q is capacitance multiplied by the voltage applied across the capacitor. Now in the upper branch Q is equal to CV will be stored, then in the lower branch also Q is equal to CV will be stored. That means total 2 times CV will be stored. So that much charge is provided by this source, the battery or the power source, energy source. Now if you assume that the combination have effective capacitance C effective, I am going to write down C effective, I am going to the next page. See, C effective multiplied by whatever voltage you are applying, this is going to be equal to Q total. This is the main logic we are applying in this problem. So C effective multiplied by voltage is going to be equal to the charge in first capacitor plus charge in second capacitor. The first capacitor charge is nothing but capacitance multiplied by voltage. Again, same value for the second, lower capacitance. You can see that same voltage. So because it's a parallel connection, so we can cancel out this voltage. That means C effective is going to be equal to C plus C, or which is equal to 2C. So here answer is 2C. So we can say that even though there are 3 capacitors in the system, is effectively same as 2 capacitors connected in parallel because this is effectively short circuited. There is no voltage across that capacitor. So here answer is 2C. I hope all of you understood this.